Hello and welcome back to the channel. In today's video, we are diving deep into a crucial aspect of API testing that every developer should be familiar with: load testing with Postman. Load testing is all about understanding how your API performs under different levels of demand. Imagine you are preparing for a big event where you expect a huge number of users to hit your service simultaneously. Load testing helps you ensure that your API can handle this traffic gracefully without crashing or slowing down. Postman is widely known for its user-friendly interface and powerful API testing capabilities. While it's primarily used for functional testing, it also offers features to perform basic load testing right within the app. And the best part, you don't need any additional tools to get started. In this video, we walk you through how to set up and execute a load test using Postman's collection runner. We will cover everything from preparing your collection, configuring your test run, to analyzing the results and interpreting performance metrics. By the end of this tutorial, you will have a solid understanding of how to use Postman to simulate load and assess your API's performance. This video is perfect for developers, QA engineers, and anyone involved in API development and testing. Whether you are a beginner or someone with more experience, you'll find valuable insights and tips that can help you ensure your APIs are ready for real-world usage. If you found this video helpful, make sure to hit the like button, subscribe to our channel, and click the bell icon to stay updated on all our latest content. Alright, let's dive into the exciting world of load testing with Postman and make sure your APIs are ready to handle any challenge that comes their way. Let's get started. Alright, let's take a quick look at this code. What we have here is a basic setup for a minimal API in ASP.NET Core. If you are new to minimal APIs, they are a lightweight way to create HTTP APIs with minimal configuration. Just a few lines of code and you are up and running. You can see that we are using map get, map post, map put, etc. methods to define our endpoints directly in the program.cs file, making things super streamlined and easy to read. If you are curious about learning more about minimal APIs, make sure to click the link right above this video to dive deeper into how they work. For this demo, we are focusing on the to-dos API, specifically the get method that retrieves all to-dos from our list. We will use this endpoint to create a collection in Postman for load testing, which will help us simulate multiple requests to see how our API handles the load. Let's jump into Postman and set up the collection. Okay, run the application. First, open your Postman and make sure you have your collection ready in Postman. As you can see on the left side of the screen, we have multiple collections. Today we are going to create a new collection and then add this endpoint to the collection. After that, right click on the new collection and select run collection. Now let's go over the settings on the right side under the functional tab. Run order. You will see the order of requests in your collection here. In your case, we have one request that's a get request to the to-dos endpoint. Make sure it's checked, indicating that it's included in the run. Run manually. This is the option we are using right now. It allows us to run the collection directly within Postman. Schedule runs. This is used for scheduling collections to run at specific times, but that's more for automated testing over time. Automate runs via CLI. For advanced user, you can run collections through the command line using Postman CLI tools. In run manually, there are three parts to create our load test: iterations. Here we've set it to 50 iterations. This means the collection will run 50 times in total, which is perfect for creating a light load scenario. Delay. There is a delay setting of 2 milliseconds between each request. Adjusting this value can simulate different loads. Smaller delays mean more intense load. Data file. You can also use a data file if you need to send different data with each request. This can be helpful for testing how your API handles various inputs. Persist responses for a session. You might want to check this if you need to keep track of each responses for debugging later. Turn off logs during run. This option is handy if you are running a high number of iterations and want to save on memory usage by not logging every request. Finally, once all your settings are configured, hit the Run New Collection button at the bottom. Postman will start executing the collection according to the settings you have applied. You will be able to see the progress and results in real time, including any failures, response times, and other performance metrics. Now let's hit the run new collection, and this is what you should see. At the top of the screen, you can see an overview of your run. For our test, we ran 50 iterations of the request to todo's endpoint. The total duration for the run was approximately 5 seconds and 763 milliseconds. The average response time is shown as 2 milliseconds, which is pretty fast. This average is calculated across all iterations, giving us of how responsive the API is under load. Below the overview, you see each iteration listed with its own details. For instance, iteration 1 to 5 are visible here, and each one shows the HTTP method GET, the endpoint being hit, and the response status. Each request returned a 200 OK status, indicating all requests were successful. The response times for these iterations range between 2 milliseconds to 3 milliseconds, and the response size are all consist at 263 bytes. One of the first things you should check is the consistency of response times. In our case, most responses are coming back in 2 to 3 milliseconds, which is stable and indicates our service handles the load well. You should also look for any failed requests. Here you can see the failed indicator at the top, showing that there were no failed requests. A high number of errors could indicate that your API can't handle the load. Similarly, the skipped count shows that no requests were skipped. Skipped requests can happen if Postman decides not to execute a request, often due to prior failures in a sequence. The past count is 0 because no tests have been defined for these requests in Postman collection. In Postman, after you make a request, you can write tests using JavaScript in the Tests tab of the request to validate response data, check status codes, ensure certain conditions are met, etc. The message "No tests found" at the end of each request indicates that there are no test scripts associated with these requests. Postman is essentially telling you that while the requests were executed and responses were received, there were no tests defined to evaluate those responses. To fix this, you need to go to each request in your collection and add test scripts in the Test tab. For example, you could add a simple test like this to check if the response status is 200. By adding such tests, you will see the past count increased as Postman runs and evaluates these tests against each response. So after testing our endpoint using the functional tab in Postman, where we focused on making sure our API behaves as expected, returning the correct responses, handling edge cases, and passing all our defined test cases, now we switch over the performance tab. This is where we get to simulate real-world traffic and put our API under various load conditions to test its robustness, reliability, and scalability. Essentially, the Performance tab is all about understanding how well your API performs when faced with multiple users, varying load patterns, and potential stress scenarios. In the middle of the Performance tab, we see options to set up your load test. Here's what each setting means. Load profile. It means the number of virtual users remain constant throughout the test. It has four options. Fixed load profile maintains a constant number of virtual users throughout the duration of the test. For example, if you set 20 virtual users, Postman will simulate 20 concurrent users continuously hitting your API without any change in user count. Use the fixed profile when you want to evaluate how your API performs under a steady load. This is ideal for baseline testing to see how your API handles a specific number of users without fluctuation. Ramp up gradually increases the number of virtual users over time. For example, the test might start with 5 virtual users and increase to 50 virtual users over 10 minutes. This simulates a growing number of users, such as a website experiencing increasing traffic as more users log on. Use ramp up when you want to test how your API handles an increasing load, which is useful for understanding the scalability of your application. A spike introduces a sudden surge in virtual users, which is followed by a return to the normal load. For example, you might start with 10 virtual users, spike to 100 virtual users for a brief period, and then drop back to 10 virtual users. Use a spike when you want to simulate sudden bursts of traffic, such as flash sales, marketing campaigns, or unexpected high demand events. Peak load profile sets a gradual increases to a peak number of virtual users and then maintains this peak for a period before gradually reducing back to the initial level. For example, it ramps up from 10 to 50 virtual users, stays at 50 virtual users for 5 minutes, and then ramps down to 10 virtual users. You speak when you want to simulate a predictable traffic pattern that has a high peak followed by a decline, like the daily traffic pattern of many websites that peak during specific hours. Virtual users. This setting is currently set to 20, which means 20 simulated users will make requests to your API in parallel. This helps you to mimic how your API would handle multiple concurrent users. Test duration. This is set to 10 minutes, meaning the load test will run for 10 minutes. During this time, those 20 virtual users will continuously send requests to your API, allowing you to observe how the system performs over a sustained period. Graph section. There is a graph placeholder on the right side that will visualize the performance metrics once the test runs. This can include response times, error rates, and throughput, which are key indicators of how your API is handling the load. Now we set the load profile to fixed. Select 100 virtual users and set the test duration to 1 minute. After setting these options, we hit the run button to start the test and see how our API performs under this load. Now let's check out the results. During this 1 minute test, our API handled a total of 2,234 requests. We averaged around 34 requests per second, which is pretty impressive for 100 virtual users consistently hitting the server. Looking at the average response time, we've got 22 milliseconds. This is really good. It means our server is responding almost instantly even when bombarded with requests. There is a quick spike at the start, which is pretty normal as the system adjusts, but it stabilizes quickly and stays low throughout the test. The average response time remained very low, peaking at just 22 milliseconds and showing a minimum of 2 milliseconds with occasional spikes up to 5 milliseconds. This indicates that the server handled the load well with no significant latency issues. Alright, after conducting our first performance test using the fixed option, now we can move on to the next test, which I think is much more exciting than the previous one. To perform this test, you need to select the ramp up option from the load profile. After selecting this option, a graph will appear below where you can adjust the test by changing the settings of the graph to match your desired scenario. The test will start with 25 users, which you can adjust using the initial load section. For example, you can set it to 30 users. Then, by adjusting these two sliders, you can change the timing for increasing or decreasing the requests through the number of users. For instance, I set the first slider to 20 seconds, which means that for the first 20 seconds, your endpoint will operate with the 30 users that you selected in the initial load section. After that, the number of requests will gradually change from 30 until it reaches 100, which is between the two sliders. Once it passes the second slider, the number of requests will continue at 100 until the end of the 1 minute test. You can also change the number 100 using the virtual users settings. Alright, now that we have set up the configurations, let's click the run button together and check out the test results. We started with 30 users, as said in the initial load. For the first 20 seconds, the graph shows that the requests per second started at a lower rate and then started to increase. From 20 to 40 seconds, we ramped up from 30 users to 100 users. This is the key part of the ramp up profile. It gradually increases the load instead of spiking immediately, which helps in understanding how the server handles progressively increasing load. You can see the gray line increasing steadily during this period. After hitting the 40-second mark, the number of virtual users stabilized at 100, which is exactly what we set as our max. The system maintained this load for the final 20 seconds of the test. The average response time stayed super low at just 2 milliseconds, even under full load. That's really good. It means your server is handling the load well. The peak rate was about 55 requests per second when the virtual users were fully ramped up. By the end of the test, we sent a total 3,819. Not bad for a 1 minute run. It's a clean sheet, 0% errors throughout the test, which is exactly what you want to see. No requests failed, so all users got their responses successfully. This test gives a solid overview of how the system handles increased load over time, starting with 30 users, ramping up to 100, and then holding that load provides a realistic simulation of a growing demand scenario. So if you are looking to validate your API's performance under growing load conditions, this ramp up test profile is a great way to visualize how your server scales and where its limits might be. Keep tweaking those settings to match your specific use cases, and you'll have a great load testing setup in Postman. Alright, let's talk about the last two load profile options, Spike and Peak. Now, I'm not gonna dive into these step by step, but here's a quick rundown of what they do, and then you can go ahead and test them out on your own. Spike is pretty straightforward. It's designed to simulate a sudden, sharp increase in traffic like what happens during a flash sale or when a link goes viral. You'll see the number of virtual users spike up instantly and then drop off just as quickly. This helps you test how well your API handles sudden surges in traffic. The peak profile, on the other hand, is like a mountain. You'll see traffic gradually build up to a peak, hold there for a while, and then slowly come back down. This is great for testing sustained high traffic periods, like during peak hours when everyone's hitting your API at the same time. These options are awesome for seeing how your system handles sudden changes and prolonged stress. So go ahead and try them out on your own. Just set them up in Postman. Click that run button and analyze the results to see how your application performs under those conditions. Alright, let's quickly recap what we covered today. We started with a functional test to ensure our API is working as expected under normal conditions. Then we switched gears to performance testing, diving deep into the fixed and ramp up load profiles. We set up the fixed test to simulate a steady load, which is great for understanding how your API performs under consistent traffic. After that, we moved on to the ramp up test, where we gradually increased the number of virtual users, simulating a growing demand over time. We also touched on the spike and peak load profiles with a quick summary. For a spike, you'll test how your API handles sudden, short bursts of traffic, while peak helps you assess performance at specific high traffic moments. We didn't dive into these tests step by step, but you can definitely explore them on your own to get a full understanding of how your API reacts to different load scenarios. So that's it for this session. I hope you found these insights valuable for your API testing journey. If you like this video, don't forget to like, subscribe, and hit the bell icon so you are notified of future tutorials. Thanks for watching, and I'll catch you in the next one. Happy testing!